Hey there, so today I want to show you how to create a reproducible environment for development and production for a Node.js application using Docker and Docker Compose. And I want to create a small demo application to show you how to achieve this. First of all, we'll just create a directory, and I'll just call it Docker Node. And I'll just bootstrap that application. And as you can see, we are already provided with a package JSON that includes all the basic information. Next, I need to install some dependencies, which is Express, which will be the web framework that we'll be using, and Mongoose, which is a document mapper for MongoDB, and it will also pull MongoDB library as a dependency. So now this is already added to our package JSON, and what I want to do first is pin that versions to ensure that we always get the same dependencies when we install it. And second is I want to create a little start script for our application to ensure that we can start our application using that npm start command. I will just be node index.js. Okay, so next thing we need is the entry point for our application, which is that index.js file. I'll just include Express itself and Mongoose. And then we need our application instance. Okay. So what I want to create is just a simple demo route for having a basically working application. We get our request and our response, and we will just always respond with hello world. And then we need to start our web server on port 3000. And I will just print that we are serving. Okay, so that should be it. And if we run that project on our local machine, it should already work. So we are serving here, and when we start that page in a browser, we see that we are already provided with the output of our route. Okay, so I would just like to start creating a Docker image for that application we've already created before we start using the database. So we can do this by creating a Docker file for our application, which will basically just provide all the information on how the image is built. And we will inherit from an image that already exists in the Docker Hub, which is Node and provides a basic environment for running a Node application. And in theory, we could use latest here, but I want to be specific. We will use version 8 of Node. And I like the Alpine images more than the ones built on Debian, because they just consume way less space. So this is more the minimalistic approach. So we will use this as a base image, and then we will just add the source code of our application, which is in the current directory, which is referred to as a dot. And we will mount that on user source app. So this is where our application lives inside the container. And additionally, I want to set our work dir to the same path so that we can execute our comments in it. And I want to create an entry point which will be executed directly when we start that image. And this will be located in user source app docker entry point.sh. So I think we don't need the full path to that script here, but anyway, we'll just leave it like this for now. Okay, so in theory, we could just build our image now using Docker build, but as we need a second image anyway, and we need to somehow compose it, we will just continue and create our Docker compose file, which will orchestrate those containers that we need for our application. So we'll create that file called Docker compose, but let's maybe first create that Docker entry point to just have anything together. So we have our shell script, and for now I just want to run npm start, which is the command that we created earlier on. And as always, we have to give execution permissions to that script. And then we can just maybe try running it, and it should already work now. So here we are serving now. And now we can build our docker compose.jml file, which will have a definition of which containers we have and how they are configured. So first of all, we will set the manifest version of that file to version 3, which is the most current format. And then we can define our services. And for now, we only have one service, which is our app. And we already have the Docker file created. So we want to enforce Docker compose to build the image upon start. So we will just set the build context to the current directory where our Docker file is placed. And we want to expose port 3000 on the host system and map it to port 3000 in our guest system. This is where our Node web server is listening. And for now, I also want to override the source code of the application that we copied in the Docker file to just be mounted from the host so that we can modify our application in development without having to rebuild the image all the time. So we will just create a volume and we will mount the current directory on the host system to user source app inside the container. Okay, this should be it. And now we can just try to run Docker compose app. Oh, I've made, this should be ports, not posts, of course. Okay, now as you can see, our container is built and started, and we're already serving. So we already have created a container for our application, and we can test again if it still works. Yeah, here we go. So our hello world is still visible and our application is running inside the container. And if we stop it now, we should not be able to access it anymore from the browser. Just kill it. Okay. So this is step one. So our application is running basically, and this should be okay so far. Next thing we need is to somehow incorporate our database now. So we'll just edit our source code again. We already imported Mongoose before. So now I will just establish a connection to an imaginary database running on the local system, or inside the same container, which also does not exist. We'll just take localhost for now and call rdb test. And because Mongoose, like every other Node library, uses callbacks by default, which is a pain in the ass, will be reconfigured to use ECMAScript 6 promises. Okay, and inside our main route, we will just create a post where we need a model first. So we'll create a post model, and let's just give it one property, which is the title, and this is a string. And inside our main route, we can now create our post. We'll just set the title to test, and delete this, and then we can save our post. And when it's saved, we will just send a response to the client and saying post is saved, like this. Okay. Obviously, this will not work now, because when we start our container again, it will probably crash directly, saying that we don't have a connection to localhost on the part that is used for MongoDB. And this is because we don't have MongoDB installed in our container. But rather than installing MongoDB in our container itself, we should create another service for our database and just establish a connection between the app container and the database container. So let's create a new service called DB, and I will use the Mongo image. To be honest, I don't know what the latest version is, so sorry. We'll just look it up. So Mongo. Current version is 3.0, and let's also be specific here and take the most detailed version like this. And in theory, we would also need to create a persistent storage for the data in our database now. And normally this is described in the README file, saying somewhere that you should have a persistent container. Yeah, in this case, it's data.db inside the container, which should be made persistent in order to have persistent data storage. So we can just say volumes. So you could either create a persistent container volume, or you could just mount it from the host, and I think we'll just go the easy way here and mount it from the host. We'll create a directory called data, and we will mount it to /data/db inside the container, which is where Mongo stores its data. And what we additionally need now is we need to establish a connection between both containers. So I will just use link or links, I think links, and we will establish a link to the DB container. Okay, so let's just create that data directory and then try if it works. So let's again run docker compose up, and we'll now pull that image from the registry. Should just take a few seconds. Oh, I just recognized that this is of course not the newest version. So 3.4.4 is the latest version, so we'll just change this again. But now at least you see that updating a container is relatively simple. Hoping the data structure didn't change. And now we need to just run docker compose down to delete our containers. Come on. Okay, and our docker compose up, and it will now use the current image. Okay, so we still have that problem in our application that we cannot connect to localhost, because still on localhost, which is the app container we just created, is no Mongo database running. So we will need to change that, and in our main application we will just exchange that localhost with the name of the container that we link to, which is just db. And when we try to do this again, it should work. Okay, so we have that serving here, so our application is running again, in theory at least. If we test it now, we should get post is saved, and yeah, so our application should be running. So the problem is that we still cannot ensure that when we run docker compose up and both containers are started, because they are started in parallel, that db is already running when the app container is ready. So it could be the case that app is started first or is ready earlier, and tries to connect to the database, but the database does not run yet. And then our whole application setup will crash, which does not make sense. Therefore, I want to just create a little workaround for this, because earlier on we created that docker entry point.sh. And as a quick workaround, I just want to add a loop here that waits until the connection to our database is ready. So I will just run netcat to try to connect to our database. And as long as this fails, we will just say waiting for the DB and sleep 1 second to not kill our database directly. So this should work. And because this is hard to reproduce, we will just enforce to not have our database running when we start our application. And therefore we have to remove the link to that container, because otherwise it's always started. Okay. Now when we start our application again, sorry, excuse me. We will just start our app container without having the database running. And we should see now, that is waiting for the database connection. So our application will not start until the database is ready. Okay, so that this works, we can just create our link again, start our application, and this should be working then. So we have serving, and again, we can refresh our application and it's still working. Okay, then this is already it. Thanks for watching, and if you have any further questions or comments, just feel free to add them to the comments. Thank you.